Hi, this is Dr. Anthony Revis with Watch Me Work It. I'm going to work through molar mass, moles, and gram calculations in this particular one. Okay, here, let's start with some molar mass calculations. Here you're given a composition, carbonate here. And so you're given this molecular formula. And so what we do is we simply count atoms or elements, each element. So this is lithium is what I would have here. I have two of those because you read this way. And so I have two of those and I would have one carbon and I would have three oxygens. Again, I'm reading this way. And so what I'm going to do, I'm going to go to the periodic table and find the values for these directly from the periodic table. And I'm only going to write these to two decimals only because that's how many I'm just writing. There's nothing magic about that. You make a decision and you live with it. And so I'm living with writing to two decimal points here. And so what I would do is I would simply do the math for these and I would do that on my calculator so I don't make any mistakes. And if you do, you just erase and you start over. Don't worry about it. Don't sweat it. And so this is 48.0, assuming I made no mistakes. And so I would then summarize these. I'd sum them up, just add the numbers together right on my calculator. And I would give the units as gram per mole. Must give units, okay? So this is my square in answer for that. Here I have magnesium nitrate, so I have one magnesium, but now the nitrogen gets a little tricky because I have to do the two times that. So two nitrogens, and then I have to do the three here for the oxygen. So that's six oxygens times 16.00. This is going to be times 14 or whatever number I have there. And then we have magnesium here is going to be 24.3. And this will be 24.3. And this is going to double. It's going to be, next one's going to be six times that number. It's going to give me 96.00. So you're just watching me work right through these. And I only did these to two decimals, again, for convenience, gram per mole. That's my square in answer for my molar mass of these compounds. All right. So now what if I want to determine moles and grams and things of that nature? In this case, how many grams are in 4.5 moles of sodium sulfide? When I see a problem like this, I recognize as my given. I recognize I'm looking for grams, so I'm going to write it out here. This is basic dimensional analysis. So I'm going to take my given is 4.5 mole, and that's 4.5 mole of sodium fluoride. I want to start to track what it is here, very important. And so it's moles on the top here, I put moles on the bottom here, sodium fluoride. That's right away, without thinking, without doing anything. And I happen to know that I can take grams of this. It's allowed in chemistry. Gram per mole is a ratio, is a relationship. But I don't know what this is. So I have to do one sodium, one fluoride times whatever those values are from the periodic table for these. And let's see, looking those up right here. Yeah, and so that's going to be 22 point, I should have said 23 here. But that's okay, I have it now. And this is going to be 19, about 19, I believe this, yeah, 19.00. And when I add these together, I get a 41.99 gram per mole for this. So this is 41.99 grams for every 1 mole. I punch these numbers through on my calculator. And in this particular case, I get 188.955. But there are two sig figs in this. So I'm going, my square answer is going to have two sig figs. I'm going to round that to this number of, what am I looking for? Gram. That's why I circle it, so I won't lose track of it. Gram of sodium fluoride. Two sig figs, two sig figs. I'm done. How many moles are in 98.3 grams of aluminum hydroxide? So I have 98. So I start here with 98. That's my given. 0.3. I'm going to note my sig figs already. 3 sig figs. I just thought of them. I know I'm looking for grams out here. How many moles? Thing I'm going to circle and keep on it. So I have 93.8 grams of what? AlOH3. I'm just tracking that, so definitely don't lose track of it. since I have gram here, I put gram here. So gram of aluminum oxide here, and I know I can go to mole. That's allowed. And I'm just writing all the units here to be clear about it. 1 mole of this is how much? Well, I have to do the calculation. So you have aluminum, and we have 1 aluminum. That's 3, 3. So I have 3 oxygens and 3 hydrogens. And if I look on a periodic table for these values for this particular compound, let's see. So it's going to be 26.98 from the periodic table, oxygen 16, and hydrogen's 1, or close enough to 1. So these numbers work out. Excuse me, when I do the math across here, you can multiply those through 3 times 16, etc. across, do your math, and in the end, okay, times that, times that, times that. I punch those through, all done on my calculator in parentheses, and I get this number here, gram per mole. So then I come over and I go 98.0 gram per mole. I punch this number through on my calculator, and I get 1.2601, but I only need 3 sig figs. So my final square-in answer is going to be 1.26 mole. Okay, that's my square-in answer for that one. Okay, you get it? All right, watch me work a couple of others. Let's say if I have this, a box of salt contains 737 grams of sodium chloride. I took time and I took my box of salt and I weighed it out. And that's what it came out to be. How many moles of sodium chloride are present in this box? So I'm looking for moles out here. And it's moles of sodium chloride, just to be specific. We'll look for moles out here, and I have a given with 3 sig figs. So my given with 3 sig figs, my answer needs to have 3 sig figs. So I take this number, 107 grams of sodium chloride. I right away, I have grams here, so I need grams on the bottom. So this is going to be grams of sodium chloride to moles of sodium chloride. So there we have it. But I don't know that. I just don't walk around with that number in my head. So I have to figure it out. So it's 1 sodium and 1 chlorine times. So approximately 23 here. So 22.99 times that gives me 22.99. Ridiculous for me to do this, but just to show you the process. So you can see it all how I do it. Watch me do it. And so here I get 35 point, whatever that is, 25. I add these numbers together and I get 58.44 gram per mole. So I put that in for my sodium chloride is 58.44 to every 1. When I punch that number through on my calculator, let's see, did I punch it through both ways? Here, boy, gee whiz. All right, in the end, didn't punch this one through. Calculator's playing. Okay, can't find my calculator. So I know it's going to give here when I punched it through. I'm going to get 3 sig figs. So let me just give you that number. Sodium chloride moles. That's when I punch it through and I get that value because they're 3 sig figs. Okay. We could do just one more of these. How many grams of chlorine are in calcium chloride? This is kind of a fun one to do. So we look for grams. It's chlorine, and we're given with 3 sig figs. So we have 10.2 calcium chlorides gram. So right away, I do my dimensional analysis, go grams of calcium chloride. Now, this is going to go up. You can never take gram to gram in any of these. So I got to go up to moles of calcium chloride. But I'm looking for what? Grams of Cl, not calcium chloride. So I'm going to have to interconvert. And so to do an interconversion, I'll take mole on the bottom. When you do this interconversion, it's going to be mole over mole. Any interconversion is going to be mole over mole. So a mole of chlorine. Then I can go mole chlorine to grams of chlorine and get my answer. So let's go back and put these numbers in. If I play through the molar mass of getting to calcium chloride, if you work this through, this is going to be it's going to be, excuse me, 1 times calcium, look that up, and 2 times Cl. Get these values all from the periodic table when you do these. All right, and so you work that through, and what you'll end up with when you sum this for the molar mass, you know how to do that already, I'm sure. So the grams per mole of this is going to be 110.98. So where did I get this from? This is the molar mass. Molar mass for every 1 mole. Now, this is what you want to watch for. Chlorine, how many chlorines are in this? There are 2 of them. I just simply look at it. 2 chlorines in this. So I have 2 chlorines in every one of these. 2 in every one of these. That's how you think about it. Well, okay, not 2 to 2. I have 2 in each of these. Okay, and then the molar mass of chlorine somewhere about 35.45, straight from the periodic table. And when I punch this through, in the end, 3 sig figs, I get 6.52 grams of Cl. That's my square in answer. And you watched me do it, and that's how you do it.